Hey there, Math 112 fans. Going to talk about page 2 of this exam. Again, we knew this was coming. The moment you see point of inflection, that's talking about when the concavity changes. The moment you think about concavity, you're taking the second derivative. So this was 9x squared minus 6x, and the second derivative is 18x. And this is the big skill. You're definitely going to see stuff like this in the final again, because I want students to be able to leave this course with an understanding of how to analyze functions. All right. So when this is 0, it's when the concavity might change. You solve. You get x is 6 over 18, which is a third. Again, this is for this version of the exam. The next step, which hopefully we've gotten better and better at, is to analyze. So what happens if you're less than a third and if you're bigger than a third? And this is where we're comparing what we're learning from the second derivative and what that tells us about the original function. So what does the second derivative tell us if we plug in a number smaller than a third? So like if you plug in 0, you should see it's negative 6. It's negative. That means this is concave down. That's the picture I always draw. It's part of a frown. If you plug in something larger than a third, like a 10, it will be positive. It's concave up. And that confirms what we're expecting, that that's a point of inflection. So to me, that was a slam dunk question. I told you it was coming. So there's not much else to say about that. But be ready for any question about concavity or point of inflection. You're probably going to have to do it again on the final. Be good with that. Okay, then we had this one. This question was directly from the homework. Again, don't mean that negatively. But if you're someone that says, because I've had people say to me, well, I don't know how to do story question. I don't know what to do if there's words. If the words are identical to a homework, you got to be ready. I've had some students say, but there's too many homework questions. You could go through the homework probably in like 10 minutes and make a note of the wordings and have everything ready. So this is something you can prepare for if you're worried about it. But I also said this was coming. So anyways, you're given this, and this was talking about how to analyze functions. So step 1, what is the function it's asking about? It's asking about total revenue. So some people, did stuff they kind of didn't need to do, but it doesn't hurt. You could integrate and get that total revenue is this. It doesn't hurt to do that. It's good to write what your function is. That's where we're starting for this part. But the moment you see decreasing, you should be thinking about slope. This is the same as saying positive, negative slope. So again, the big themes of the term is when you take the derivative of something, that represents the slope of that thing. Now that already is marginal revenue, so we really didn't need to do that previous part. And the moment you're talking about slope or increasing or decreasing or max or min, take the derivative, set it equal to 0. And you might say, why did I take the derivative of that and not marginal revenue? Because the question was about total revenue. This is my starting function, so to speak. You solve this and you should quickly get x equals 30. Again, there's 2 versions. You draw your number line. This is the fundamental of trying to teach you a general approach for inflection problems, for increasing, decreasing, for concavity. So I was teaching you this number line approach just to figure out what's happening before or after. And here's where you think about the derivative, and here's where you think about the original function. Okay, so you plug in a number less than 30, you get a positive, like for example, we put 0, and that means you're uphill. You plug in a number bigger than 30, it's negative, it means you're downhill. So when you're decreasing when you're bigger than 30. So what's happening is students are setting the wrong thing equal to 0. They're grabbing the wrong function. I don't think that's because it's a story question. I mean, the question directly tells you. This is not really a story question issue. I think it's self-doubt. You can give me a feedback on that piece, but nobody's trying to trick you here. All right. And this is what I was trying to get us to practice when I was posting videos before. Anyways, Last thing, AC has one critical value. So this was pulled directly from an old exam. It also was identical to exam 1. Exam 1, you had to do almost the same question. You do something very similar. So I was like, okay, if students messed up the algebra on exam 1, at least they've seen it. So if you didn't know how to solve this, that might suggest you didn't review exam 1 when we did it. That doesn't mean you had to go back and study exam 1. We needed to, when you encounter something in a course and you get it wrong, on a test especially, you got to figure it out immediately and not make that mistake again. That's a lesson I'm trying to teach here. Okay, so the question is about average cost. It has one critical value. So the average cost is our starting function. 16x to the negative 1. And if we're still making mistakes on rewriting functions, that's a big thing holding us back here. Then we need to take the derivative, negative 16x to the negative 2 plus 0 plus 1. We need to set that equal to 0. And those of you that have been keeping up with my advice, I always like to say, the moment you're done doing calculus, it probably will look better if you rewrite it the way an algebra student would write it, meaning rewrite it this way. And I've talked many times about how the moment you see a fraction, it's a really good idea to clear the denominator, multiply everything by x squared. Now again, that's a tougher algebra question, except for the fact that we did the exact same thing on exam 1. And we did it in our review session. So you get two possibilities, plus or minus 4. 4 is the only positive one. So let's look at what's happening here when you're above 0. That's what the question was about. So now I'm going to think about what's going on with y prime, which in this case is AC prime, and y. So I need to plug in something here between 0 and 4. So how about 1? If I plug in 1, it's negative. If I plug in 5, you get like 16 over. That's okay, so it's positive. It's downhill, it's uphill. Critical value is 4, and it's a min from our analysis. That's not going to go away. That's going to appear again on the final. Let's show you a few things. So there's the solutions. There's the other version. The other version has a 4, a 25, and a 5. I do want to point out, if we look at this, because I know people are going to say, well, that algebra was hard. Here that was on exam 1. So this is mostly a lesson I'm trying to show you of when you take a test, you need to reflect and review on it because you don't want to miss the same thing again. So if you missed this question on exam 1 and then you missed it again on exam 2, that's an important lesson for the future as you take other courses. All right. And you should go through, this is going to be a major topic of the final because it's the main topic of the course. So if you look on an old final, here's a question here. Here's two functions. What's the global max and min from 0 to 8 for g of x? Do we know how to do that? When is f decreasing and g decreasing? Do we know how to do that? Find one critical number of this. How do you do that? Here's another function, analyzing. What's the largest? To me, those are all the same questions we just were doing. And I want you to see that. Okay, so it'd be really good to work through these couple problems. Don't look at any solutions. Don't look at any notes. See how far you can get on your own, and then come show me your work in office hours. I would love that because then I can give you precise, I can see where you're stuck. And that's going to make you do better on the final. All right, hope that helps.